Hey, hi folks. How is everyone doing? I see a lot of hellos. Hi Sushmita. How are you? Hey there Tony. Hi. That's so awesome. Learning coding is an awesome process in itself. So you're gonna enjoy a lot. Hey, hi. Hello folks. So, how is everyone doing? How have you been? How is your global happy going till now? Hey, hi, a lot of hellos now. Hello, hello. So, I'll just get myself set up and we'll be good to go. So, um, sure. So I'll, convey this in just a few moments, and you'll all be able to know what we're gonna do in this three-part workshop series, and what we are actually gonna build, what dApp, right? So, hello everyone. Today we are going to dive into the exciting world of decentralized applications or dApps. So, where we are going to start by getting an overview of what exactly dApps are, learn a little bit about blockchain, and then get an overview about Ethereum and smart contracts, Solidity, its basics, etc. And in the next part of this series, which is tomorrow at 1:30 p.m. IST, so in that we're gonna write our first smart contract for our to-do application. So, we're through the Solidity basics we're gonna learn today. We'll try to write a smart contract, modify it, and then in the third part of this series, we'll try to integrate our front end with the smart contract, deploy it on a local blockchain. We're planning to use Ganache, which is a local blockchain simulator. And yeah, that's it. So I'll walk you through the entire process. I'll help you set up your development environment. And from tomorrow, we're gonna put some hands in actual building of the application, decentralized application actually. So for those who are watching me for the first time, let me introduce myself. I am so there is a question over here. Sure. So I'll address this first. So, hey Pralay. So there are not actually any kind of prerequisites, I would say, but it would be quite helpful for you all to learn about, Solidity if you are already familiar to OOPS programming languages such as Java or JavaScript. So this will help you to, help you a little bit in programming in Solidity for the first time. So that would be my suggestion. Also, we'll be building the front end of the application in React and MUI library, which will not be very complex for the people who are not familiar with React. I'll go through the entire piece of code for you all to make it easier. So I see some pizza comments already. So let me introduce myself before I further say anything else. So, hey, hi, folks. I am Khushi Mahavar. I'm one of the coaches at Major League Hacking. And a fun fact about me is that I really revealed it already for you all. So, I'm in a very serious relationship with pizza. So, in case if you all are, pizza lovers like me, you can, you already let me know. So, we can, hang out and, you know, talk about pizza someday. So yes, sure. I was just about to post the OHQ link. So here, there you go. I actually like. First of all, make sure that you register and check in yourself. So there is a question. So I actually like cheese burst pizza. I usually order margarita cheese burst, but any kind of cheese burst is favorite for me. Sure, someday for sure. But today we're gonna build a to-do application, dApp, decentralized application. So no, not at all. I was suggested to taste once, but I don't think I would ever. So people are excited over here. So let's get started without any further ado. So yeah, let me just do a quick setup. Fine. So let us start with the introduction of dApps. What dApps are actually? So dApps, in simple language, stand for decentralized application, as you all might be knowing. So let us look over this picture over here. You all use, smartphones, and you all are aware about the applications you use. So you might be using Facebook, Instagram, Twitter, and now we have another app from Instagram, which is Threads. So we all use that kind of applications. So imagine these traditional applications where you are able to interact with these applications. So whenever you use these apps, you the applications interacts with the central authority or a company's server. So to display something on the front end, the applications are responsible to access the backend code on the cloud server or some central authority, right? So dApps are quite similar, but they take a different approach from accessing the backend code from cloud server. Instead, they use a decentralized network, as you're able to see here in this picture. So whenever they need to, access a backend code, they'll go and access this decentralized network. So this means there is nothing which is controlling that. Actually, no single person is controlling a decentralized application. Very similar to the way people organize. You all organize parties where there's need. You might not need one single person to arrange the party. Different friends can control the party. One friend brings something to the table, one friend handles music, one friend does something else. So this is how actually dApps are running, giving you a very basic idea. So okay, can you please share that Google Drive link for sure? Since today we'll not get started with the building of the dApp. Actually, we'll learn about the basics, and from the next workshop we'll get started. So sure, I'll share my GitHub link for that so that you can access the repository. So I hope this idea gave you an understanding of what dApps are actually. We'll learn more about it. So let us read out this definition as well. dApps are built on decentralized network, as we just read, and which is supported by blockchain distributed ledger. So do not get intimidated by this big word. They're out of control of central authority. They're not being controlled by a central person or some authority or some server, unlike the traditional applications we use. So now, before we talk more about dApp and it becomes more sophisticated, let's learn a little bit about blockchain and then jump into it. So yes, sure. Beginners in programming can learn dApp, of course. As I told, if you're an understanding of little bit of OOPS concepts, that was actually my observation that if a person knows OOPS, it is not very difficult to understand Solidity. And if you already know HTML, CSS, JavaScript, or frameworks like React, Angular, it will be easier for you to integrate the front end with the Solidity smart contract. So don't worry at all, it's gonna be super easy. So now let's get an overview of blockchain actually. So before I read out this definition, which might make complex, I'll just give you an example. Imagine this example for more simplicity. So imagine you are a part of a big group of friends, and you all play video games together, and you love playing video games. So now you all want to keep track of what all happened in the video game, who won the first game, who was able to beat that person in that game, and etc etc. A lot many activities, who purchased what in the game, what item in the game. So but here's the catch, that you you all do not want to rely on just one person, because you might not be, feel, trustworthy for each other. So you might just not want to rely on one person. So what do you exactly do? Are there some comments you want to put down, so that we can discuss? Try to relate it to blockchain if you know it already. So you don't want to trust only just one person to, keep a track of what all happened in the game, because you are afraid that he might alter the activities, or make it beneficial for himself instead. So I'll let you know. So what you can do is you can create a special notebook that everyone has a copy of. So if everyone has a copy of that notebook, it would be easier to keep track for everyone, not just one person. Everybody keeps track of the school. Right, exactly. Awesome. So this notebook is very much like blockchain. It's a shared digital record book that contains all the transactions, or let's say records or activities that happened within a game or any other system. So, what makes it unique is that once something is written in this notebook, nobody can change it without anyone else knowing it. So, if we all are here, we people are here, and we all have each copy of that notebook, and if I try to change something, you all will, I cannot change it without you all knowing it. If I change it, you all be able to know that I changed it and I am doing something malicious in blockchain, right? So this is how it makes it more secure. So anything, if it's on that notebook, it's there forever, right? So instead of a single person or company being in charge of this notebook, it's managed by the entire group. So each person has a copy of this notebook, and whenever a new transaction happens, everyone in the group gets together to validate it and add it to their own notebooks. This way, everyone stays in sync and has the same information. So, why is this important exactly? That might be one of the questions some of you might be thinking. So, well, it brings a new level of trust. You were not able to trust on just one person. So now, by sharing this copy, sharing this ledger to multiple people, you are able to trust and feel secure about this. Since now everyone has their own copy of notebook, it's really really hard for someone to cheat or manipulate the records. So even if he does, he'll be caught. So it's like playing a game where no one can actually cheat because everyone is watching, right? So also notice that blockchain technology also is removing the part of intermediaries. For example, the central authority we saw in cloud server. So here we do not need any of that. Moreover, think of, like, for example, if you want to make a transaction through one party to from one account to another account, you'll have to make a request of this transaction to a bank or some company, let's say. But in blockchain, you'll not be needing any central authority or some bank. So it removes the intermediary parties, and this verifies and processes transactions. It's like having a direct connection between the accounts of players, where you can receive money or record the activities, transactions without relying on a middleman. So it's fast, transparent, and can even save you some fees. So let us read out this definition of blockchain as well. A blockchain is a digital database or ledger that is distributed among the nodes of a peer to peer network. So, blockchain is based on a decentralized network. So, this data, which we talked about, which were the activities recorded in the game, these are being stored at different nodes of a network, right? Very similar to those group of friends. The nodes are the friends, and the data is actually the activities you or the transactions you wanted to store. I hope you get got an overview of blockchain here, and you can just put a thumbs up or something over here. So here we're gonna build a web application. So I don't think As far as I know, this architecture is regarding Android application or something. If you could clear me out. Fine, awesome. So, and now that we talked about blockchain, here is where dApps come into the picture. A dApp is like a game or an application that runs on blockchain. Unlike regular apps, dApps are not controlled by any central authority or a person or a company. Instead, it runs on a big network of computers that are owned and operated by many people. So, here, by many people, many nodes, I mean those friends who were actually dealing with the network. So they're open. These dApps are actually open source, if you know. So you can choose if you want to make it an open source by putting a license on. And these are transparent as well, which means everyone can see how they actually work. They can see the logic of this app, decentralized application. So it's like having a window into the app's kitchen where you can see what ingredients are being put and how everything is being cooked up, right? So fine, let us move ahead to the next part of our workshop. Any example of dApps? So I'm not quite sure of popular examples which you might have seen. So we'll go through this. I'll tell you a tutorial for this, which is very easy to interact. There is a pet shop tutorial of Truffle Suite, which you can unbox and download it and simply run it, and you'll be able to know what way dApps actually work. Fine. So let us now get started and understand about Ethereum open source blockchain. So, so Ethereum is an open source blockchain which introduces the concept of smart contracts. So if you know about Bitcoin already, Bitcoin does not include smart contracts. Ethereum is a blockchain which does, and we'll learn about smart contracts a few moments later. So Ethereum takes the idea of blockchain and expands its capabilities beyond just recording transactions. So Bitcoin is a blockchain as well. It is responsible for just recording transactions. But as you okay, let's talk about the example that we just discussed, which was about the group of friends who loved playing video games. Here, we were not recording transactions. We were not recording where money came from and where it went. We were recording the activities, who was the winning person in the game, etc. So Ethereum allows you to do that. Ethereum is not just restricted to recording money transactions, but also recording activities or anything you wish. So that's something which Ethereum is capable of. So like Bitcoin, it utilizes a decentralized network of computers or nodes to maintain a secure and transparent ledger. However, Ethereum takes it a step further by introducing the concept of smart contracts. So also Ethereum has its own native cryptocurrency, if you know, which is called Ether. So also another thing I would like to mention is that this Ether is actually used as a fuel to power the execution of smart contracts. So uh, what usually happens, to do something you have to pay, right? You need to give a fee. So this fee is actually the gas or the ether you're gonna pay for, that keeps the engine running. And by engine I mean that the smart to make the smart contract run or deploy. So whenever you interact with a dApp or deploy a smart contract on Ethereum, you'll likely need some Ether to pay for the computational resources used. So if you are deploying a you will see this tomorrow, that whenever we deploy a smart contract, even on a Ganache, we'll have to pay some amount of Ether for that, and that will not be much. Some right? It sounds interesting. So we'll have to pay some Ether from our account. So now that I've said a lot about smart contracts, let us, actually learn about smart contracts. The coolest thing about dApps is that they use smart contracts, which is based on Ethereum. So smart contracts are actually like digital agreements. So let us think. Oops, I'll just okay. So let us think of a regular contract you might sign, like a rental agreement. So it's a document actually that states all the terms and conditions between you and the landlord. So you both have to trust that each party will fulfill their obligations. But what if we could have contracts that automatically, execute themselves without relying on this trust criteria? So we'll not just have to trust on each other. We'll trust this smart contract, which will have all the logic, all the terms and conditions of the agreement, and which will automatically execute itself. So that's where these smart contracts come in. Smart contracts are like self-executing agreements, which are actually written in code. So by agreement, I mean that those terms and conditions, which are in programming. So these smart contracts live on blockchain, and once they're deployed, they operate exactly as programmed. So whatever you program in smart contract, after deploying, they'll act. They'll self-execute themselves in that way. So let's go back to a rental agreement example over here. Instead of relying on a paper contract and trust, we can create a smart contract. This smart contract would contain all the terms and conditions and of the rental agreement, like monthly rent, due date, conditions of returning the security deposit, etc. And once it's deployed on the blockchain, it will automatically enforce this. So, being a if there is a landlord, and if I am paying rent to him, I need not just check out my agreement all the time. I can just rely on this smart contract, which will self execute it all the time and enforce these conditions. So, and when the lease ends, the smart contract can handle the return of the security deposit based on the agreed upon conditions. So, I can, pay through the smart contract, and whenever it can forward it to the landlord. Very simple. The beauty of smart contract is that they remove the need for intermediaries. Here the bank was not involved, any intermediate party was not involved, while me and the landlord communicating and creating an agreement, right? Otherwise, I'll have to bring some lawyer who will have to create an agreement for both of us, and through that lawyer's agreement, I'll have to work on his terms and conditions. So no third party was involved here, and no intermediates involved. So because the code here is acting as a middleman itself. So it's like having an incorruptible digital referee who ensures that everything happens as agreed upon. So now, as I explained with this example of rental agreements, smart contracts aren't actually limited to rental agreements. They can be used for all sort of things, from financial transactions to like transferring money or buying, selling assets, to more complex operations, or even you can list out. You can create a vegetable selling application through a smart contract. So it can be used for unlimited sorts of things. So, right. And these dApps actually run on smart contracts. Hey, Tintin, how to proceed for writing a blockchain smart contract? Thanks. So, right, today what we're gonna do is we'll first get introduced to Solidity, which is the programming scripting language for Ethereum. We'll learn a little bit of its basics, and then we'll jump on to write a smart contract for a small smart contract for maybe let's say student, and then tomorrow, or if time allows us today, we'll start writing our first smart contract for the to do application. So yes, we're gonna use Solidity. I'm planning to use that because the Solidity is the most common language for creating applications. Can you sum up by explaining dApps relate to how they're related to each other? Is that so? So, okay, what all? So, right, if you understood about blockchain is nothing else but a decentralized network, let's say. So, here different nodes are there, and they're, sending information. They all have access to information without any third party being involved in that. Now, for example, let's take an example of Ethereum blockchain. It is able to, it has the capability to record more than just transactions, such as activities or anything that this person sold this thing, or this you bought this thing, you added a task into your to application, etc., etc. So in the smart contract, we're actually writing this logic, or it's an agreement actually. So we are writing a programming agreement, a programming logic for your decentralized application. And once you have written a smart contract, you can deploy it on a blockchain, which is Ethereum. And to complete your dApp, which is your decentralized application, you can build a front end as well. You can deploy it on IPFS, which is also a decentralized file storage platform. So and through that you can complete your decentralized application and actually use it. So yes, that was a little bit of summary. So now I would also want you to know a little bit about Solidity, and then we can put some hands on Solidity. So Solidity is a high level contract oriented programming language. So as we know some of the languages which are object oriented, this is contract oriented. So specifically designed for writing smart contracts on the Ethereum platform. So if you observe today, it is syntactically similar to JavaScript or Java. I found it very similar. So that's why if you already know Java or JavaScript, it will be easier for you to understand it. So Solidity is a high level data, okay, that you know. Once the smart contract is written in Solidity, it will actually be compiled into bytecode, and this low level representation of bytecode will go to EVM, which is Ethereum Virtual Machine. I'm just saying this for you all to know how this actually works. So EVM is able to understand this low level representation of smart contract, and it is actually the runtime environment where smart contracts are executed on the Ethereum network. Okay, just give me a moment. um, Difference between backend and web3: expect decentralized or secure or open. Actually, I didn't get your question exactly. What difference are you expecting over here? Difference between backend and web3: expect. Okay, accept. Difference between backend and web3: except decentralized. Backend and web3. Okay, I think you got something wrong over here. Backend is something where you actually put your logic of the application, right? So in traditional applications, you write your logic either in Java or use JavaScript or Node.js, for example. um, but in web3, we're writing our logic through smart contracts. Fine. So these smart contracts will get deployed, and okay, in more simpler terms, in traditional applications, what do we have? We have front end, we have back end, and we have our database, right? So in Web3 applications such as dApp, which is dApp, so we have front end again, but for the logic building, for the backend code, we have smart contracts, and the database in is actually the blockchain. So in naive terms, that is something how you could compare both of them. Fine. I hope that addresses and clears a little bit for you. So okay, cool. So before I now start covering the Solidity basics, let us set up our development environment. So these are some of the things we're gonna need to build our application. You can simply go on to node.js, https this link. I'll also simply show you by sharing my screen. You'll have to wait a second. Fine. You can go onto this link and download it according to your operating system. If you are using something else, you can go here and download it. Simple. I think most of you might be having Node.js, or if you don't even have, you can simply go ahead and download it. And then, okay, I didn't add it to my, okay. I hope it's visible now. Right. This is the link I have described. Go on to this link, download it simply by clicking over here. Since I've already downloaded, I'm not clicking. So you can take this actually as your home assignment. No, you are not late. By how long do you mean about the workshop? It's a 2 hour workshop, and it will actually run from 12:30 p.m. IST to 2:30 p.m. IST. You're not late. If you have any query, others, you can put over here, and we can go back to our basics and revise them. It's or current. What do you mean? For Node.js, you can this one, LTS. Okay, I wasn't sharing my screen and was so confidently saying this one, LTS one. What kind of misconfiguration? I think you're already, familiar with smart contract. I don't understand what kind of misconfiguration. So, and then next, what you have to install is the Truffle suite. So simply go onto your command prompt and then write on this command. I'll just open the command prompt for you and share my screen. Oh, it's here. Oops. Can I not share my command prompt actually? Why am I not getting an option? So never mind. I'll just let you know this command. So once you have opened your terminal or command prompt, simply write npm install global truffle. Type this onto your command prompt, and your truffle will get installed globally. Yes, that is it. Simple. I was trying to show it you on my command prompt, but it's not being shared. I don't know why. So also to confirm whether the whether Truffle suite actually installed, check out the Truffle version by using this command. So yes, what is Truffle? Right. So Truffle is actually a suite which comes off. It's a development environment for building dApps. It comes with a lot of tools which will allow you to build smart contracts easily and test them. So how do you explain? I hope that was enough for this. So the next thing is Ganache, which you will need to download. So Ganache is actually a local blockchain simulator. So as Ethereum is a blockchain, so we're not obviously going to deploy this on Ethereum because we'll need some ether and we do not have. So we'll use Ganache blockchain simulator for that. We'll deploy it over here, there, test it, and so to download that, you can use this link and go onto this link and simply download Ganache. What are the best practices, do's and don'ts for writing blockchain smart contract? So I would say, Tintin, please calm down. We are just gonna jump over there. We'll write a smart contract, and I'll let you know with the basics, and you'll be able to write some good smart contracts then. And the next we have VS Code. I hope you might all be having it. If you do not have it, you can simply install, do a Google search, and simply install that. I have never tried Node.js before. Is that okay? Yes, for sure. That's fine. So, if you have not worked on Node.js before, if you're not actually gonna work, Truffle actually needs Node. That's why we're installing it first. Yes, actually. So whenever we write a smart contract, we want to optimize it so that it takes the least amount of gas fee. So that is not something we're gonna cover here today. Also, one of my friends was building a gas optimizer project. So that is something you might need to know about. So for reference resources, sure, I'll post these right now. I do not have um, here right now with me. I can post them later on Discord on or later after the workshop for you all. Yes. So for VS Code as well, do a simple Google search, install it. Also, you need not just do all of this right now, because we'll begin with all of this stuff tomorrow. So you can take it as a home assignment and do this. Yes. So coming on to the MetaMask wallet now. So MetaMask wallet will allow you to handle all your accounts, Ethereum accounts, etc. So you can install a MetaMask extension. I'll share my screen. Just give me a second. Fine. So just search MetaMask wallet extension and go on to this Chrome extension, which is MetaMask. I've already added it. So it, I just get this option for removing from the Chrome, but you all can just add it to your Chrome, and that's it. The later process of MetaMask, we can do it later for sending and receiving Web3 money. Exactly, in short. So this makes your process easier to handle all your accounts and interact with the decentralized applications. Fine. Thank you, Adarsh, for posting the link. Okay, cool. So you can just add in to this Chrome extension, and you are good to go. So also we'll be using React and MUI library, but that's for later. And don't worry if you're not familiar with React. It's actually pretty straightforward, especially if you already know HTML, CSS, and JavaScript. So let me explain a little bit about React as well. React is a component-based structure. So it allows you to create components, break down your user interface, and create components for a different part of the interface. And then you can call those components and reuse it all the time. So one thing you will notice in React is that it uses a syntax called JSX, which actually combines code of HTML and JavaScript. So sounds a little complex for you, but trust me, it's nothing to be intimidated by. It's just a slight difference, and once you get the hang of it, you'll see how. Throughout the workshop tomorrow and the day after tomorrow, I'll guide you through the code step by step of React, explaining the purpose of each line. We'll start with a basic setup and gradually build upon. Fine. So now that we have talked a lot about, let us cover some basic concepts of Solidity to get started with writing smart contracts. So for introducing the basics to you all, I'll be working on Remix ID. So to install, you can also install the Remix ID desktop. Um, but I'll be working on the web version. So let me just share this to you all. Fine. So you can, let me check over here. So this is a web version. You can either install the desktop version or simply work on this one. So the way you have ID such as VS Code, Remix is very similar to that. We are using an ID to build a smart contract. So here, if you see, these are the folders. So you might be getting a default workspace, and here some of the folders such as contracts, scripts, tests, etc. The rest are made by me. So in this folder, if you open one of the folders such as storage.sol, this is one of the basic smart contract, and we can start learning from here. So here, if you see at the top, this is the license identifier. So whenever you start with the source code of Solidity smart contract file, you'll need to have to mention a commented license, which could be any license identifier. Actually, what happens is smart contracts are open source and transparent. So whenever you deploy a smart contract, it's open. Everybody can see the smart contract or even use it in their projects. So that's why you can also choose if you want to list out the smart contract as open source or not. If you do not want this to be open source, you can simply write here as unlicensed. So I'll just show you. Um, these are some of the ways you can actually add an uncommented license identifier. There might be more, so you can google and choose which kind of smart contract license identifier is much applicable to your application. So that's it. And then the next thing you need to ensure that you add in a smart contract file is that you add pragma keyword along with the solidity version. So this version will actually help you to know which version of compiler will allow it to compile. So this is some of the way you can write the solidity version. So do not put so much mind into it. So you need not write this everywhere. You can just simply copy paste it. Very simple. So now let us look at this contract. Okay, some comments. Let me just have a look over the comments. Okay, okay, cool. Fine. So here, if you see, we'll also code out something, but I'm just giving you a glimpse. If you remember in Java, we write as class. We name something as class, right? We write class student. And in that you write a constructor, you write some state variables, you write a function. This is very similar to that. Here, instead of class, you are writing contract, and inside that you are declaring a state variable, you are declaring functions, and you can also create a constructor, but here it's not, so not required. So here, the way to initialize a smart contract is that you first of all write license identifier, pragma solidity version, then you start writing the contract. You name a contract, and inside that they have written a state variable. So this state variable is actually an unsigned integer of this size, right? So you can also create integer as well. Let me comment this. It's an unsigned integer. You can also simply create an unsigned integer using uint num. Instead of just mentioning the data type size, you can simply mention this, and it will take the maximum amount of size of num. Fine. This is an unsigned integer. If you want to write an integer, write like this, int a. So right now we'll cover this. Let me just skip it for now. So is that fine? Now you remember we used to have some getter setter functions. If you are not familiar with that, let me tell you. Getter setter function allows you to set the value of state variable using a user input. Fine. So this function store, if you check out this function store is the name of the function. It is taking a parameter which is num, and then it's storing the value of state variable as num. So it is nothing is being done. It is just changing the value of the state variable. The next is retrieve, which is actually retrieving the value of this number, which is the state variable. So here we'll just return the number. Let us once compile and test it. So for compiling it, you can simply do a control S, which is save, or else click on this button. I hope it's visible to you. Actually, Raga, what we're doing, I'm planning to, teach some basics of Solidity using Remix. I wanted you all to know about Remix as well. So that's why I'm doing that. But for building the dApp, we'll use VS Code. So for today, you might, use the web version of Remix. Okay, cool. So once you have compiled it, you can see, click over here and you can see it says compilation successful. If you go below, you'll see deploy and run transactions. So here you can simply deploy it, and below you see you can actually give an input of the number and store it. So let us add this number 25 and store it. Once you click this button, you can see that this transaction was actually successful. So, yeah, you made the first transaction. So, you have stored a value of 25 on this to this state variable, which is to the blockchain. So, the number is now 25. So, now when I retrieve this number, I'll get the value 25, right? So, let us retrieve it, and you see the number value is 25. You win 256 is now 25. So this transaction was successful as well. So this was simple, very simple way of storing and retrieving a value of number. So how to detect fraud, intrusion, or clauses plagiarism on the program code of a blockchain smart contract. So I'm not quite sure about this. I think I can get back to you with some resources because I myself have not worked on this level of smart contract that I check the plagiarism. But I'm quite sure that you can use pieces of code of smart contract from other smart contracts because it's open source. But yes, if you talk about the plagiarism, I'll have to check myself. So are you using Remix? Yes. Web version of Remix ID. Is it storing the value 25 in blockchain? I don't understand. So let's okay, let me make it easier for you. So this number state variable is actually this value is actually being stored on this transaction. This transaction of adding this number 25 is actually getting stored on blockchain, and while this state variable is handling the value. I hope that makes it clear. So so don't worry for this right now. When we'll get started to build the to-do application, we can go over there and check out how the folders such as contracts, scripts, tests have been aligned so that we can get some more idea. There are these buttons called call data and parameters. What are those? Okay, let us check out that as well. So for call data, these are low level interaction. So I don't think we'll require this in our to-do application. But for example, if you are sending some amount of ether to your smart contract, you might need to transact some value and send data to contract. So for example, if you're sending some ether to contract, You can simply click over here and transact some amount, some, for example, 10 ether to your contract. So I am not quite sure if you would be understanding this right now, because that is something which comes to the later part of smart contracts when it becomes pay when the smart contract becomes actually payable. So calm down, folks. Slow down a little bit, and we'll get to those later. Okay, cool. So this was very simple. You added the parameter 25, you stored it to the state variable number, and you retrieved it. Fine. So let us, I'll just create a small a file. You can actually create a new file by going over here, and let us well. So first of all, what is the idea to do in this smart contract? What do we do first of all? Can we save that number permanent in solidity for every account? What do you mean actually? Can we save that number? Mm, for that account? Not actually, because you'll deploy it every time, so it will get vanished. So every time you deploy a smart contract, you'll have to add and call that function again to store that value. Yes. Also, before that, we'll have to add the commented license identifier. So for simplicity, let's just copy paste it from here. And notice that the license identifier here has been used as MIT. You can use anything as I showed. There is more GPL 3.0. Otherwise, there is an unlicensed version as well. So right, next what you do is you create a contract. Let us name this contract as them. Fine. Now let us add create an integer a. What do we do if we want to create an unsigned integer? We do an uint b, and in case if you want to create an integer with a specified data type size, you can do uint. Let me just uint 8, uint 16, uint then you have 32, 256, etc., etc. Right, you can do that way. So also, if you want to add a string, you can simply write string message. Right, this is how we're gonna use data types over here, and we'll learn a few more now. So so today I also wanted to add this, that today we'll learn about solidity basics. Not the entire, we're not gonna deep dive into this basic thing, but we'll learn the amount of basics we'll need in our to-do app. So later after this workshop, what you can do is learn more about solidity, try to create some basic smart contract for anything you like, and that will be more helpful to you all. Fine. So, is it disturbing? Fine. So now what you can do is that let us create a function. Okay, before adding a function, I'll also want you to know, for example, in languages we know, for example, in C++, you can simply do a multi-line declaration. You can add two variables together and declare it. But if you try to do that here, it will give you an error. Let us compile and check if the smart contract we have written till now is fine or not. It simply gives us error over here. It says it expected semicolon instead of the comma. So in short, multi-line declarations are not allowed in Solidity. So let us now create a function. Okay, let us also check if till this it's fine. If it compiles successfully, you're writing a fine smart contract. So let us create a function. Fine, the function, you write the function keyword, then you name the function. So let us give this function name. What do we give? Uh, Let us just write func, and then let us add some parameters. So I'm writing int a uint b. So that is the usual way to define a solidity function, right? Is that so? So this is the usual way you define a function in other programming languages. But when you do this in Solidity, it will throw you some errors, and you see it's already throwing in some errors. First of all, it says visibility, no visibility specified. So whenever you add a function to a Solidity contract, you need to use some access specifiers. So for that, you need to either mention your function as public or private, or whether it's internal or external. You use private when you want to use these functions only limited to the contract. But you when you want to view when you want to be able to view these functions, you actually use public. So mostly you will observe that we'll use public. So right now, is that fine? There's another error that I'll let you know what happens now. So in usual programming languages, you write the you are allowed to write the parameter name same as the state variable. But here you are not. You can write anything except a or b over here. So instead of writing something num or num1 num2, we can in a practice of Solidity smart contracts is that you just add an underscore to the state variable name in the parameter. This makes it easier to identify. Then now, if I want to assign the value of the state variable a as underscore a, I can simply do this. Fine. Let us compile this, and it compiles successfully. So I hope you are till with me till now. So I would suggest you to explore this, and we can get back to this tomorrow. You really need to study this about, and you'll get to know more information. So I told you about public private. Go explore about this. Yes, uint is unsigned. Did I do something else? Ah, okay, there's a question. So yes, integer is from negative infinity to positive infinity. So, but uint starts from 0 to positive infinity. Oh, yes, exactly. There is no this keyword. So, that's why we cannot actually use the same name of state variable in the parameter. What does the first, which line is that? Is we Are we talking about, is this one, or are we talking about the function? Okay, let me know whenever you want to take these things a little bit slow, because this might not be, might be a little new to you all. So now that we have set the values of A and B, let us actually get this data. So, okay. And before, retrieving this data, let us retrieve a number actually, just a number. So let us get 10. You'll get to know what I'm actually doing. So to retrieve a number, you do not actually need some um, parameter, right? So notice that I'm actually writing public here for the function, and now let us write return 10. Right? So I'll try to compile it, and we'll look out for the mistakes. So fine. This is the way we used to do in another programming languages such as Java or C++, right? But here, what do we do is to write a function to retrieve any number or anything, we'll have to also mention the return data type, which is you actually do. If the function is not returning anything, you used to write void in C++, and if it's returning anything, you used to write int. If it's returning an array, you'll write vector int, etc. So here also you'll have to mention, so it's returning the int. I wrote that it's returning me an integer. So let us run. But again, I'll have to let you know that okay. So whenever there are two things you need to know now. Let me think of how I should explain it to you all. So there are two keywords you'll have to use in function. So just check out this error before we talk about anything. Function state mutability can be restricted to pure. You understand mutability? Mutability means if this can be changed or not. So it says that mutability can be restricted to pure. So this, let us do that first and we'll talk more about it. It's compiling fine now. So here adding pure means that this smart contract, this function is not actually reading anything from the blockchain and is also not manipulating the state variables of smart contract. Had it been returning this or calling changing these values, it we would have used something else over here. Since it's not doing that, it's not reading anything from the blockchain, it's not manipulating the state variables, we are using pure. It's a pure thing. It's a pure function. You understand that, no? Okay. So let us just deploy it first and test what we have done till now. So here, if you see, there is a deploy button. Deploy it, and there is a function. And now it's asking me expand this function. It's asking me to write give a parameter value for underscore a and parameter value for underscore b. So let me give a value, let's say 5 and 3 for b, right? So and transact it. You see a successful transaction happen. And what I'm doing now for the get 10 function, I'm returning 10. I'll just return a value of 10 and it actually gives me 10. That was a very simple thing we did. Now let us try to get value of a. Get a. I'll just set up. Yeah. So we know that we have to make this function public. We know that we'll have to add a return data type because if we want to return the value of a, what is a? The state variable. Here is the state variable, and let us try to compile it. We get an error. So what does this error say? It says that function state mutability can be restricted to view. Earlier, it suggested us to put this as pure because this function was not reading anything from the blockchain and was not manipulating data on the blockchain, right? Neither the smart contract nor the data. But here, this function is trying to read something which is on the blockchain, which is a, the state variable. It is trying to read the value of a which is actually on the blockchain. So something, whenever you are trying to read something from the blockchain, you'll have to add view. That you are just, this ensures this tells the smart contract that you're just viewing it, you're not changing anything from the blockchain, right? So this will help the smart contract to know. Now that I have added view, it's compiling successfully. So let us deploy it again. Deploy. So the second deployed contract is below now. Expand it. Write the values of a. I'm adding a is 5, b is 3. Transact. Ex- uh, a successful transaction happened. Now let us get the value of a. And you see 5 has been retrieved, which was the value we passed for a. So I hope you understood the difference between pure and view. Pure is used when you are not changing anything on the blockchain, when you're not reading anything from the blockchain. But if you're reading something which is stored on blockchain, if you're reading the values of state variable in simple, you need to use view. So if it was using something in the contract, we would use view like your previous contract. The previous contract, which was the storage contract. So, in short, please understand that if we are using, yes, okay. So you guys are so awesome. Before I say anything, you already have an idea of what we are doing. So, in short, whenever we are reading the value of state variable, you use view. And if you're not reading any value of state variable, you're not changing the value of state variable or anything on contract, you will simply use pure. That function is pure. But what if you want to change the value of state variable? What do you do? Any idea? Let us change the value of a. What do you do now? At public, and let's just simply change the value of a. I'm not returning anything. Okay. Let us change a. I want a to be increased to a plus 2. Now what do you do? Let us check if it's compiling fine. And to our, notice it compiles fine. So whenever you're changing anything, you need not add any keyword. So also, whenever you are actually making a change onto your smart contract, compile it every time and then deploy it. So now that I have deployed it, let us first add the value of state variable a and b. So I'm adding a as 7, b as 4, and let us transact. So our transaction was successful. Let us at least check the value of a. Yes, it's 7, which is correct. Get 10, we know it will return as 10 because we had sent the value 10. Now let us change a. Once I click this button, the a's value should be increased to a plus 2, which was 7. So now it should be 7 plus 2, which is 9. So let us call this function get a again to check whether the value of a has been changed or not. And when I call a successful transaction happens and it shows 9. So that means our change function is working fine as well. I hope this all I see is a boilerplate code, huh? So right now we are learning basics. So once we know about some keywords and we know how to actually use them, we'll be able to actually use in our smart contract. So here view was not required since we were actually manipulating the state variables. So need not write anything over here. So now I believe you all know what we have been doing in this. So let us also do create another function and convey a message. Convey function which takes some message. Also, you cannot use message if I add, see, check out this. If I add my keyword, my variable name as message, it displays differently. Actually, message is a keyword. So that's why, you know, try not to use that. Let's use this. So here we'll take a parameter message and return this message to the user. Return message, and since we're returning something, add this. But let's see what happens. Here you get an error. So what error? Okay, another error you'll see. Yes. So let us see this. Here it says that the data location must be memory or call data for parameter in function, but none was given. So here, whenever you're using string or some struct type data structure, you'll have to add keyword memory or call data. So there are keywords such as memory, storage. So memory is something which actually shows that this value of message you're gonna give is not being stored on blockchain, but it's being stored temporary in the volatile memory. So had you used storage over here, if you had used storage over here, this would have been stored on an expensive and space in blockchain. So rather, because we do not want to actually store it, we use memory, and this is how you'll have to add it everywhere. I think this is me. So Since where you are using memory, you need to add it here also. And also, is this function accessing anything from the blockchain? What do you folks think? What should I write over here? Should I write pure? Should I write view? Or should I leave it blank? Pure, exactly. So happy to see that. Okay, so we have a view as well. We'll discuss about this. So okay, cool. So let us try adding view and pure. Okay. So if I write pure, it compiles successfully. And if I write view, let's see what happens. It gives me an error. So function state mutability can be restricted to pure. So we use view when we do not actually want to, we actually want to read something from the state variable or blockchain. But here, if you notice, we haven't stored anything over here. Have we stored anything? We didn't even use string message, right? We're not calling the string message. We're just calling this variable, whatever we have passed in the parameter, just return that. So we are not accessing the state variable. We're not accessing changing anything in the contract. So that's why this function could be restricted to pure. Simply compile it and let us deploy it again. Deploy. Go on to the. Uh, I'm not here. It is. So let us add values. I don't think it's required now. Let's convey a message. Convey message hello world. And this conveys the message. Whatever I pass into this parameter has been returned to me, which is hello world. I think all of these basics allowed you to understand how exactly we are, setting up the getter setter, what access specifiers we are using, and how we can use string in solidity. Don't tell me you were not able to hear me till now. Am I audible now? I have been speaking so much since then. Oh my god. Better. Okay. Better. So much better now. Why does this happen? Hmm. Okay, could you just confirm, Amber, that you were able to hear me earlier or not, or I was not able to, you know, a little bit of static. Okay. So you were able to get this point of pure and view, right? Thank you. I got so worried for just a moment. Yes, fine, fine. Then that's fine. So I think this is fine. Let us actually try to, does it go blur when I switch my windows? I don't know. So let us try to write a smart contract for, let's say, we can do it for a doctor or student or anything else. Let's write it for a student. That is very simple for you all to understand. So what we do, I have written down the question for me. So what we are gonna do is we'll write a smart contract where we'll uh, use a student roll number to uniquely identify him, and we'll store his name. We'll store his marks um, for one subject. Right? We can expand this also, but this might get complicated for you all. So let us do that. So we're going to store three things. We're going to use his roll number, we're going to use his name, and then his marks. So Let me create a new file. Yes. Okay. Student. Already have a student name. Let us say name is first contract. Also, I forgot to tell you that whenever you're creating a Solidity file, make sure to add this SOL extension. One of the basics you need to know. Now, first of all, we'll copy paste this so that we have our license identifier and track our Solidity version. Now, let's name our contract. We can name it student. Let us name it from here as contract. Mm, Fine. So now what I want to do is I want to store three things for each student. Okay, I'm confirming again whether I'm audible or not. Just put us quick yes here. Yes, fine. Thanks, others. So let us, we're trying to store three values. Roll number, it will be int, we know, or two int for better. Okay. Then we know we'll need a name, string name. Then we know we'll need int. Let's keep it int. Marks can be negative as well, right? So we'll use three variables for each student. But what we're gonna do here is create our own data type. If you do you all know struct? If you have studied C, you might be already familiar with struct. So here I'm creating my own data type which is struct, and here I'm gonna I'll write it again. These values: student roll number, string name, and then what did we thought of int marks. So I have initialized a struct data type and added these three variables we'll need in that. Similar to class, yes, yes. So I hope you might be getting a glimpse of what we are doing here. So I've created a struct, and now what I'm gonna do is, uh, what did we think of? We wanted to use roll number as unique identifier. Actually, it's the key. Roll number is the key. So for roll number one, roll number, okay, I'll just put this commentary part. Roll number one, I want the student name. I will store what? I'll store student. For roll number one, I want the roll number one to be stored. I want the name, for example, Akansha is stored. I want the marks 60 to be stored here. For roll number two, I just want to explain you how the roll number and value mapping is happening over here. For roll number two, I'll be storing two. I'll be storing another name, and I'll be storing some marks. Fine. So the roll number will be able to identify the value of the student struct. So it will allow us to access the value of the roll number one's entire date. So if you are you all familiar to hash maps or unordered maps or anything? So if you're not familiar to hash map, that is hash map also works in the same way. So for example, if I'm talking about roll number one, so this roll number one is a unique identifier. It is a key which will allow us to call all the data for roll number one. So for example, let me you might not be 18 plus. Are you all folks 18 plus? So if you have a bank account, for example, if your parents have a bank account, so the bank, whenever you visit the bank and ask them to check your account balance or something, uh, that's fine. Others, then I think that you can think of for your parent. So they'll ask for your phone number. The bank employees ask for your phone number or an account number. So this account number or phone number allows them to uniquely identify your data. So this is a key which helps them to simply use the key and call your data. So for example, if my account number is 52620 etc etc, so they'll simply use this account number and check out all my data, Khushi, this account balance, this account number, or this transaction on this day, etc. So they'll be able to view my data. Similarly, what we're doing for um, a unique key, which is the roll number, I'll call out the data which has been stored for this particular roll number, which could be one, which is the roll number. I'll call out this entire data, which is the roll number, which is the name, which is and then we have marks. Fine. So for this, we use mapping. So, and we are trying to map what with. I'm trying to map the roll number, which is uint, right? It is uint, and I'm trying to map it with what? I'm trying to map it with the student details. So here is the student details. This struct contains the entire student details, and we'll also have to name this mapping. So let us name this mapping as students. I hope this clears something for you all, just like the wallet address too. Yes, so wallet address is also a unique identifier. We'll use this in our to-do list tab. So I'll also explain this to you in a while. So now that we're done with mapping, let us add our student to the function. So what all parameters do we need to add the student? Another way we can do it is that instead of passing the roll number here in the parameter section, we can generate the roll number for each student every time we add a student. So let us add initialize student count as 0 right now. Whenever we add a student count will be incremented, and then the rule that particular student count will become the rule number for that student. So let us try that. I'll pass the string name because I'm automatically giving the roll number. I'm not passing the roll number as parameter here. And what I'll do, I'll make this different from the state variable name. Int marks. Uh-oh. What am I doing? And make sure to make this function public. What else do we need to do? I don't think anything else. Do we? We'll check that out. So we have done this. Now what we want to do is that we'll now first of all let us increment our student count. Since I'm adding a student, now the student count should become 1. Earlier it was 0. Once I call this function, should become 1. If I call this function again, it should become 2. So imagine I have called this function. The student count becomes from 0 to 1. So here the student count is 1. So let us assign this student count as the roll number for this particular student, right? So now what we'll do is we'll call this mapping. This mapping will hold the key of the student. Let us imagine this key is 1, which is our roll number. The roll number is 1, and we are assigning the value to this roll number 1 as student roll value and struct of student. So let us add 1. Then we are adding the name. Let us add Khushi. Then let us add the marks. Okay. So here I have added the data of student with roll number 1. But now I'm not gonna add this for each roll number of student, right? For 2, for 3. Instead, I'm trying to automate this process. So I'll just simply add student count over here. I know the student count here whenever would become 1. Once I call this function, student count would become 1. And here also, thus I'll pass the student count. And now I believe that's it. We'll also create a getter function for the same. So let us get the student details. So for getting the student details, do we need any parameter? Yes, of course we do. As we talked about the example of banking, so memory keyword. Oh, it's awesome, folks. I would like to highlight these people. Awesome. View. Do we need view? We'll check that out by compiling our application and know. So student structure is an event after mapping. No, it stays struct. It stays not exactly struct. Whenever we are creating a struct with some name, here students, becomes a data type in itself. So we have a new data type now, which is students. So I'm calling a new data type, which is students, and using that, and I'm assigning its values. I hope that clears something. And since we use string here, let us add memory. Till now, let's check and check if it compiles successfully. So it gives me an error over here. Oh, see, now we have to pass these values as the parameter, right? I'm not manually giving them some value. I'm trying to take some value from the user and assign this value to my state variables. Fine. Now it should compile successfully. Yes, it does. So now let us actually fetch the details of students. So to get the student details, I'll need his roll number. So for roll number, I'll write int roll number, and I'll mention this as public. So now here also let me address this doubt whether this function should be view or pure, or should it be as it is. So check out if this function is accessing anything from the blockchain and is modifying it. So yes, it is actually modifying the value of these state variables. So it is assigning the state value to this data type student as student count, name, marks, which has been given by the user. So yes, it is accessing and changing it actually. So whenever we change anything in the state variable, we need not write anything. And when we read anything, we need to use view, and elsewise public. So here we're gonna read. So let us use view, and this is gonna return. What are we going to return now? Let us simply return student, since it is uh, the data type we want to return. Earlier, we wanted to return a event. We were returning returns in the braces. We were writing event because it was the data type we were wanting to return. But now I want to return this data type. Struct itself is a data type, right? So this will return me all the three values for that particular roll number. So let me just write return. Um, so I'll use mapping over here. I'll call the mapping and write the roll number which the user has passed. So this shall simply return be the student. Okay, just let us compile and test, and we'll get an idea of what we are actually doing. It's compiling fine. Okay, I'm so sorry. I'm so sorry. So you guys are running ahead of me, so that makes me a little bit confused. Let us deploy it. I'll, yes, we are deploying the right file, first contract.sql. Let's deploy. It has been deployed below. So expand this function add student. Let us add the student. So I'm adding the student Khushi with 50 marks. And let us transact it. This transaction was successful, which means the value of Khushi, the roll number, and marks have been assigned successfully to this data type student. Now let us get student. So we I know myself that since there is only one student in this contract for now, so the roll number which must have been assigned to me is one. So I'll simply write one and call the student details. And here, if you see, I have got one as the roll number, then Kushi as the name, and 50 as the marks. I hope that gets you an idea. Should we return roll number in add student? Yes, that could be done. That could be done, yes. But we don't actually need that because we know that right now we are adding one student and all. Fine. Is that fine? But when you're actually building an application, you can try to find out some way where you can do that. Also, I wanted you all to notice one thing here. What if you try to call a roll number 5? What happens? It gives me a value 0, 0. 0 string is empty. I'm not quite sure. Now you'll be able to view. So it gives me a value 0 with string empty, nothing printed on the string area, name area, and then again 0 for marks. Should this even have been printed? Also, did you notice this transaction was successful? The call transaction was successful to get this value, but it shouldn't have even transacted initially because this value does not even exist. This roll number does not even exist. So why did we even pay our ether to call this function? What can we do for this? Any idea? I do not want to fetch details of a roll number which does not even exist. So what can we do that for that? Default values, okay. Uh, by default values, what do you mean? Huh, it actually does not. But let's say if you're handling a function and we are, doing something which is not even allowed in that. So what can we do to stop that so that we'll not have to pay extra ether? Also, I didn't add an if condition. So awesome. That's the right answer. But here, instead of that if condition, we'll write a require condition which handles an if. Also, did you all notice that here in the first account, we're using the first account till now, the ethers are getting reduced every time we're deploying it. And let's also check when if we view something, does it use any ether? So right now at the end it's 2963. Okay, let's call it. I called it. It's working fine. And let's check it then. So right, it whenever we call something, it is not using any ether. But when you transact something, this add student was a transaction. So this was actually using some ether. Let us transact something else now, and let's check whether it uses any ether. So let me some add some name tag or I and transacted. Okay. So this transaction was successful, and it was earlier 2963. It's now 7963, and it has been reduced more. If you observe, the number of nines must have been lowered now. So every time you're making a transaction or even deploying the contract from the same, let's deploy this contract again. Right now it's 7693. So let us deploy it again. I've deployed it. It's fine. So if you observe, again the some amount of ether has been reduced. So whenever you deploy, whenever you make a transaction, you are actually paying some ether. So this comment by Shivpreet was exactly correct. You functions are not costing us anything. But what I meant is that a required condition is something which will help you to save ether when you want to make this transaction as invalid. So let us add a required condition and set a condition that if the rule number does not exist, That is, if the roll number, this okay, this function should execute only when the required condition is met. Fine. So I'll write a required condition. I want the roll number to be greater than zero. There is no roll number which will exist and can be less than zero. Fine. I have added this condition. I'm using an and operator here, and now I want the roll number to be less than equal to student count. We all know that the roll number cannot exceed the student count. Does it ever happen with you that your class has students of a student, total students of 50, and there is a roll number which exists, which is of 55? Not possible now. And that, is there any roll number which exists which is negative one or zero or less than zero or anything else? No, we know that. So here we have added that logic. We have added a require statement that whatever parameter the user pass, whatever roll number the user passes, we want that this roll number to be greater than zero and less than equal to the student count. And if that doesn't happen, then print this message: roll number does not exist. So this prints the message that the roll number does not exist. So let us run this and check whether now does it accept the transaction call transaction for non-existent roll number. First of all, let us add a few students. I'm adding. I'll add myself. What else? I'm adding myself. Uh, did this transaction happen successfully? Let me check. I'll call the student. Yes. Let us add few more students. Let's be some names. Uh, some random names. 40. Added another student. I'll add some another person. Let us add. I've added three students. I know I can fetch their details. Second student, I'm getting Pallavi 40. For third student, I'm getting Akash 3, Akash 80. Fine. So now let me, fetch details for a roll number 5, which does not even exist here. And here, if you observe, I get that this transaction has been reverted to the initial state. Reason provided by the contract is that roll number does not exist. So this restricted me for calling a transaction which is invalid. So this is how you can actually use required conditions in your smart contract. So in this smart contract, you were able to, add students details, map his details, and then add a student, get his student values. Also, what if you want to use this require condition multiple functions? It will be quite unfeasible for you to write this require condition in each and every function, right? So instead of that, we use modifiers. What are modifiers? Modifiers you can use, you can call them in each of the function. Modifiers are actually require statements only. It's just that it makes more easier for you to just simply call the modifier instead of writing require statement everywhere in the functions. So you'll be simply able to call the modifier. So let us add a modifier here. You add the keyword modifier, you name the modifier, check roll number. Is roll number valid? Let's just write that. Is roll number valid? Right. And we'll have to pass some parameter, right? Which is the roll number. And what else? Do we need to make it public or something? No. We'll simply write the required statement inside that and simply call this modifier whenever we need it. And a syntax of modifier says that after writing the required statement, And you can write as many required statements here if you want. If you require that, um, if you want that there is a roll number zero. Hey, what else? Should I give you an example of? Let us skip it. So what I just wanted to say that you can add as many require statements here if you want. A syntax of require modifier is that after writing all the required statements, you have to add an underscore and then close it with a semicolon. And now you're done with the modifier. Now what you have to do is that just after view over here, you can simply call your modifier roll check roll number. No, its roll is roll number valid, and you have to pass this parameter which is un roll number. Let us try compiling it now. Okay, it's giving some error. Expected comma but got identifier. Oh, did we do something wrong? Returns. Oops. So we need not pass the data type over here because we have already initialized that there. And this compiles fine. Let's deploy it again and let us check if our modifier is working fine. So below is our smart contract which has been deployed. I'm adding a name K like 40 marks. Let us give 100 marks to this person now. Transact. Fine. The transaction happened successfully. Now I know this person must have gotten the roll number one. Let me call the roll number three now. And it says again our modifier is working super awesome. It gives us the result that the transaction has been reverted to the initial state. Reason provided that the roll number does not exist and my laptop is not charged. So fine. So I hope you got a glimpse of that. Um, okay, I think probably you got that. So I think you got how we're gonna create some smart contracts today. So celebrate you who created your first smart contract, which actually stores the details of student. So if you're planning to build a student management system using blockchain, you're planning to build a decentralized application, you just wrote a smart contract for that. So if so this is how the way we're gonna build it similarly for to do application. Awesome. Did you really do it for the first time? I don't understand the emoji. Is it sarcastic? Okay, and one thing more I wanted you all to know about is address. Address is actually a key identifier for you all to know, for the smart contract to know. For example, imagine there is a person. He has an account. He has a MetaMask account, and he is accessing this dApp website from his MetaMask account. So how does this dApp website know that this user, this is some user and there is another user and there is another user? So the dApp uses the account address, for example, very similar to the account number we have in banks. So for example, now if I go to open a bank account, I'll get some account number. So similarly, if you have account in MetaMask, you have an account address. So dApp uses an account address or your account address to uniquely identify you. So here let us just check out what our address is. Address to student address. Let us try storing his address as well. Add student. So I'll just add another thing over here, which is okay. I'll have to. Okay, do you think we have to pass the parameter over here? No, we need not. So passing a parameter would be stupid, right? So think of this, I'm passing a parameter over here. So I'll have to all the time here there will be another input box where I have to write my own address. That should be the way. No, whenever I open my account at some bank, they'll themselves assign me, give me an account number, and they'll simply store all my details according to that account number, right? So I am not planning to pass any account number, but I do need to store my account address. So what do we do is that we use this message.sender. Message.sender will pass, will message.sender actually gives you the account number of the person who is using this account. So the smart contract will know what account is using the dApp right now. So let me just give you a glimpse of that. Let us check if it compiles fine. It does. Let me. I'm deleting all the deployments we made. I'm deploying it again. We have a fresh deployment now. Let me add a student. Let us use a new account now. So I have an account which starts from 0xab8. Remember that. I'll ask you. 0xab8. So now deploy. Let me make a transaction with someone named as Jack and marks as 50. I just made a transaction and it's successful. Now let us fetch the details of the student with roll number one. He has roll number one. Now if you see, I'll zoom it. Oh, zoom. Okay, my trackpad is actually, troubling me. So I have to use an external mouse. I hope it's visible enough. Right. So here, if you see the roll number, we are getting one. Then the name we are getting Jack. Then we are getting 50 marks, and then we are also getting the account address through message.sender. So whichever account I use, I'll get the account address of that person will be stored here in stored address. Okay. Fine. So we use this account 0xab8, and now for Jack, the account address has been stored as 0xab8. So this will uniquely identify Jack, that Jack uses this account number. If a query is coming from this account number, this person is Jack, right? So instead of using roll number to uniquely identify Jack, we can also use his student address, which is this. So if I try to use this account now, I've already deployed it. Let us use this account, right? And I'm now making another transaction, and now I'm calling the student too. So now it gives me a different account number which starts with 0x4b. Does this account start with? Yes, it does. This account, we actually made a transaction from the account number 0x4b, and thus for the name Khushi, for the roll number 2, the account address has been stored as 0x4b, right? So let me, from this account number, from Khushi's account number, what if I try to call Jack's details? Let us get his details. And I get his account number only. I'm not getting my account number, right? Because I stored the account number of Jack in his data type. So now it's retrieving the Jack's account number only. I get one roll number of Jack, I get Jack's name, his marks, and his account number. So I hope you got an idea of how we can use address as well to uniquely identify people. Sure, Emma. Bye bye. So I hope you got that idea, because we're gonna use address tomorrow to write the smart contract for to do application. So I see some queries. Okay, that's so awesome, others. For from Remix only. I'm not quite sure because I'm just using Remix to teach you all kind of and I used it for practice earlier, but I have not pushed code from remix. So you can check out if there is any process or anything, any extension or something which allows you to do that. Can we return the whole mapping? If yes, what is the return type? Yes. So Adarsh is right over here, Shippreet, that we are returning the struct and not the mapping here. Observe that we are calling from the student's mapping, we are calling roll number. For this particular roll number, I'm calling this struct which has been assigned to this mapping of roll number 1 or something else. Fine. So I'm returning the student memory. So whatever has been assigned to this mapping of this particular roll number, I'm returning that. And what has been assigned? The student struct. So I'm returning that. Also, we can make this mapping public. Let us make this mapping public. Yeah. So once I've made this mapping public, you all can view it over here. There is another, there's mapping students. Can you all view it? Let us add some A50. I can get the student. Here I'm using my own function to get the student, but I can also use the public mapping to get the student details. Observe that I'm getting roll number 1, name, K, marks 50, and the student address. So if you make the mapping public, it allows me to get the details of the students publicly. Hmm. If I want to return students, so if you want to return students, why would you want to return mapping? Yeah, I didn't get here. You don't actually, you wouldn't want to return the mapping. Mapping is just a way which is allowing you to map the key value to the its value pair. Do you understand that? Never mind, if you're still getting confused, just go on, do a quick Google search, and try to understand mapping in solidity. I think you folks are a little, um, if I want to get all the students I have. Okay. So for that, I think you'll have to use array and push all the student details in an array, and then uh, maybe get them. So I'm just giving you an idea that we're going to use this in our to-do application, to-do decentralized application. What we're going to do is that we'll have multiple tasks for each person, right? For example, I have multiple tasks which I've added on the dApp. So to view them, I'll get the tasks together and display them. So I'll get all the tasks similarly the way you were saying, get all the students. So I'll let you know how that we can do later in the third session probably. It saves in struct. The details, yes, the details of students are getting saved in the struct data type. So that was it for today, folks. I hope you all got an idea of how we can actually write a smart contract. So in the next session, we'll set up, no, we'll first of all write a smart contract for to-do application. We'll write, in steps. We'll start with the very basic one, and then go ahead, try to make it a little more complex, and then we'll deploy it maybe on Ganache. We'll try. We'll see that tomorrow, and. Then in the third session, we'll connect our front end. So possibly, I think tomorrow also we'll be starting with the front end if we would have enough time. And then day after tomorrow, we'll surely complete our front end and complete our to-do application. So is there anything you all want to add to this session or have any queries? You can go ahead. I'm here to address any of them. For saving students' data permanently, we use IPFS. So IPFS is interplanetary planetary file storage. It will allow you to store files such as if you want to store some PDF files, if you want to store some images, videos on a decentralized platform. You do not want to store them on cloud or something. You want to store them or decentralized format. So you use IPFS for that. But if you want to, if you're talking about just students' data, you can simply store it on an Ethereum blockchain as well. Why do you want to use IPFS? I am not clear with that. And you also talked about permanent thing. So I think it would be permanent itself. But if yes, if you deploy the app again, the data will get vanished. Yes, in our to-do application, we'll use authentication. So first of all, we'll just write a simple logic of to-do app, and then we'll try to integrate a user authentication as well. So for that, we'll use address, which we studied today about. So you'll see more about this tomorrow. So I hope I addressed others' query and should read yours too. So I'll wait for a few more seconds, and if there is any other query, we can get to it. Else, we can, complete our session for today. Is there any, is the concepts of refresh and access tokens, or is it different way? Um, Refresh and access tokens by what do you mean by that? Uh, are you talking about the to-do application or something? Also, will not require any testnet ether or something if you are thinking of that. Um, since we are doing it only in Ganache for as a local blockchain simulator, and I didn't actually get your query, Shifri. Could you please, matlab, you can try to make it simpler for me, and make sure you folks come tomorrow with all of this installed. Or by all of this, I mean Node.js, Truffle, Ganache, VS Code, and MetaMask wallet. React and MUI would be done later. Like when we use Web2, we use refresh tokens to authenticate and keep sessions. No, nahin, yes, we are. I actually was planning to integrate this. So yes, we can use that. I understood now you're talking about web tokens. So yes, we can use that. I'm quite not sure if I added this into this project, but I'll get back and check. I think we're using this because I remember when I built it, I actually added it. So yes, and this should whenever you are authenticating the person, you should use that because otherwise, on refreshing, this will vanish. So I hope all the queries have been addressed. So I'll wrap up the session for today. It was so awesome to see all folks here join. I hope you had so much fun. Last question. Space is expensive on blockchain. Let's say I'm making Instagram on blockchain. Okay. Okay. So for Instagram, if you're using a decentralized application for Instagram. So you'll not want to store images, videos, or any kind of thing. Yes, I was about to talk about that. You'll not want to store images on Ethereum blockchain because that would really be very costly for you. So what do you do is for files such as images, PDF files, videos, etc. You store them on IPFS, which is interplanetary file storage system. So it allows you to store things in a decentralized way. So yes, others is also suggesting that. So you can read more about that, and you can. There are different third party which applications which allows. There is Infura, which allows you to actually store it, but then you'll need some credit card to use that. Otherwise, you can study more about that. I had also built an app which used IPFS actually, so it's quite interesting. I suggest you to read more about it. Yes, and there was from Instagram. You're suggesting, right? A friend of mine also built an Instagram on dApp, so I can connect with him with you if you want. So let me know. You can let me know in Discord or something. So that's it for folks. That's it for today, folks. I hope you enjoyed the workshop, and thank you so much. What do we get in return from IPFS, which we save in blockchain? Um, what do we get in return? We get the IPFS. We actually get a IPFS, the address. We get a unique address for everything we store. For example, if I'm storing an image, I'll get an hashed, a unique identifying address. So that hashed data I'll store into my blockchain for that particular user. And now, whenever the user, asks for that image or that file, we can use that hashed address to get that file from IPFS. So I'll suggest you to read more about it to get into the depth actually. But this is the basic idea of IPFS. It actually stores something and gives you a hashed value to store it on blockchain, which allows actually to map the data on IPFS. So I hope that clears your query. And thank you so much for attending, folks. Thank you. So we'll wrap up the session. See you tomorrow at 1:30 p.m. IST. Bye bye.